Yeah.
Because
That is the reason why, yeah, sometimes, I don't know why, but sometimes you just do that. It seems to double up. I've seen it before. Usually I just run the tests on one file at the same time, so I say notes tests and then the name of the test. Oh, but you haven't accidentally copied it?
Save it.
Like, have it in there twice? I'm just asking. It's exactly the same thing because that is kind of weird.
But
I
because
don't know how you get that.
You have to call it. Yeah, you can have it. So we can tie that's all speaking. Otherwise, it's just a combination. So that test is. So if you stick, so all we've got.
Okay, I'm going to have to move on a little bit, even though I know not everyone is completely done. So one thing that you noticed was that when I just say assert, then it didn't really give me a meaningful error. It just told me that something went wrong. So the nose test framework provides some nice tools to test more specifically. For example, if I say from nose.tools import assert almost equal, then I can test if a floating point number is almost equal. Now, someone in the back just very correctly remarked that floating points test, if you test if two floating points are equal, then that might give something wrong because the 16th digit is off. So that's where the almost equal will tell you, well, it has to be almost equal, as in down to 3 decimal places, for example. Or you can give a delta, which means like relatively they should be almost equal. Which becomes a problem when you try to test whether two things are both 0, of course. But apart from that, you're good. So definitely read up on that. This software carpentry testing lesson is more extensive. There's more info here. But I want to point out a couple of things. First of all, when you write tests, just writing 10 tests with 10 different numbers is not going to tell you much more. 2, sure, but more than 2 tests with just different numbers in my list to see whether I calculate the right mean is not very convincing. What you need to test are all the special cases, all the ones that you think might go wrong. So 0 is always a good one. An empty list is always a good one. What does it have to do? Maybe that's to throw an error, sure, but then you write a test that expects an error. What if you do a huge long set of numbers? What if the mean is exactly 0? So all those kinds of things, all those what they call edge and corner cases, well, they have a very specific definition, but what I just say is test everything that is slightly odd and therefore might give an error. And more importantly, when you're actually running your program and something goes wrong, the first thing is you write a unit test for that specific case, because that is one that actually went wrong at some point. So you write the unit test, then you solve your bug, then you test if the unit test now passes, and you will never run into the same bug again because you will always have that unit test to check for it. Even though you might rewrite your algorithm, you might speed up some part or change some part, or someone else might start messing, but you will definitely need a unit test for that case because it actually failed you once. It actually cost you an hour or an afternoon or a week debugging once. So that is the one thing. And the other thing is that we also talk about integration and regression tests. So this is different from a unit test. A unit test looks at one small bit, right? One short function, preferably, and tests that. An integration test is something else. It tests like half your program. It will test one, usually what it will do is test one good flow through your program. Now there are a couple of things that you as a scientist will immediately say are going to be extra tricky with this, which is, come on, what is going to go wrong here? If I try to...
It's complex and it's
It's very complex, yes. So first of all, I don't know the answer, otherwise I would not have written this code. Step one, right? Okay, so we can test maybe the one solution, the one analytic solution I do have. But in most cases, or in many cases, even that's not available. Step two, we might run into serious uncertainty problems. And step three, problem three, it will take a long time to run. Because there's a reason we're all here. I mean, I think most of you went to this workshop to figure out how to speed up their code. So running that test, which is the entire code, is going to take a long time. So integration tests are a little trickier, but they are really, really useful if you use them well. So what I advise you to do is run maybe 2 or 3 short, 2 or 3 tests that go through your entire program, but not very long. So for example, not integrate for a very long time. In my research, that means for less than 1 million years, but I know for many people that's something else. It depends on your field. So short time, run for a short time. Run maybe not too many, not too high resolution, stuff like that. But do run the entire thing in your unit test. And the point is that this will catch a lot of these stupid things, like that you somewhere forget to return your numbers, your result, and therefore the next function just gets none. If there's just a general exception. All these little things that are frustrating, they're relatively easy to catch, but they're even easier to catch if you have an integration test. But it doesn't usually test the actual result. So for that there's another trick, and that's called the regression test. In a regression test, what you do is, I have this integration test that goes through my entire code. I run it, I get an answer, a number. I don't know if that is correct, but I mean, you're all scientists, you do know, okay, it's not going to be negative, it's not going to be higher than the speed of light, all that kind of things. You can look at that number and say, okay, I believe this number. Then you save that number, or that image, or that array, or anything, whatever your code gives you. And then when next month you've changed your code a lot, you run it again, and you want the same number. That is the regression test. You don't know if it's correct. You just assume, well, last time I really thought about this and I figured this must be the right one. If I now change my code and the number changes, I have to seriously ask myself, why did the number change? Maybe it's very valid. Maybe you changed what you actually calculate. Maybe you included more physics. Maybe it's actually a better number right now. But maybe you just made a typo somewhere, there's a bug, and you get negative energies, whatever. So the regression test will quickly tell you, hey, something changed. You might want to have a look at this. And that is very powerful and definitely something to automate. And then I want to tell you something about test-driven development. I must admit, I have tried doing it and I don't do it very rigorously, so I will leave this up to you, but there is a lot of interesting thought in this method of development. So what is it? Test-driven development, as the name might imply, means you write the test first before you write the code. And if you're very strict, you're not allowed to write any code that does not help you pass a failing unit test. Now think about this for a while. What does it feel? What do you think about this? I would like your input. What does it make you think about?
Well, I mean, writing something to make it called generic would be justified. To work in advance to be able to tackle a function task.
Yeah, so your code won't be very generic. True.
It won't be, because you just
No, it
tailor
won't be. No, it won't be very generic. No. So that is one side. Some people consider that an advantage, some people consider that a disadvantage. But your code definitely won't be as generic as it would be if you just thought about it.
I think it's something that one does, actually, everybody does something like that before you start writing code. Because you have an idea what your results are supposed to be or what your results should be. So you have that kind of test in mind.
True. Yes. Yes, you will always, when you write your code, have some idea, like if I put this in, then I should get this out. So one of the nice things about writing the test first is instead of having that implicitly in your head, you make it explicit, you put it down in code, which forces you to think, is this realistic? One. And two, it means that you don't cheat quite as much. If you get a different answer, and it was only in your head that you expected this to be a 2, but actually you got 3, if you had written it down, then you force yourself to really think, wait, why did I think it was going to be 2? My code says 3. Whereas if it was implicit, then you often end up saying, oh yeah, no, I thought something like 2 or 3. It's basic psychology. So that is, So test-driven development, if done really strictly, is very obnoxious. For example, your first test will need to return 2, so you just write the code return 2. Yeah, I don't believe that. We actually want to calculate something. So that's not usually how people use it here. This is how they start their standard deviation, just return 1, because their first test happened to mean 1 as an answer. So that is the very strict version of test-driven development that very few people actually use. But what is nice about test-driven development is that you, by forcing yourself to write the test first, so if you think, oh, but I need this bit of code, I need to do something special if people input a number in my code that is a complex number. Right? That was the problem we were just looking at. And you think, oh, I should catch complex numbers. First you write a test for it, and only then do you change the code. This ensures that all your code is tested. So it definitely has that advantage. The other advantage is that you will never end up with those bloody long 100-line functions, because the writing the test first forces you to break that up and write little tests, write little functions that pass smaller tests. Because writing tests for very long functions is very frustrating. And if you first write your very long function, then writing the test is a lot more work. And you probably have to restructure your code while doing it. So writing tests first definitely has that advantage.
Writing tests for long functions is annoying because you have to test a lot of special cases.
Yes, because if you have a long function, well, and by long function I mean a function where you do a lot of different things. If you do a lot of different things, then you have to write a test for all of these cases. But on top of that, each of these cases has to take into account all the other things your function does. So if you have a function that first calculates a mean and then adds something, then every input will have to, every test will kind of have to go through the mean before it can test your sum function, some part of your function. Or conversely, if you want to test the mean part, then you might still get derailed by bugs in the addition at the end. So if your function does multiple things at once, then you will always have, so let's say your function does 2 things, then you will always have 4 paths through. Whereas if you have 2 functions, each doing 1 thing, then you only have 2 paths. You see where I'm going with this? That is why testing shorter functions is important. So they do end up Making a generic, yes.
In this way, say, putting the complexity of the testing from the unit testing to the integration or regression testing? Because before, after you have one expansion for sure.
Yes.
So, I mean,
but the point is that there are a lot, and I mean a lot of bugs that you don't catch in an integration test. If I had written a unit test for my Comet's collision code, I would have seen, hey, this velocity is higher than the speed of light, this is definitely not right. But in my integration test, where I took an average of 1,000 orbits, or actually 1,000,000 orbits, my velocities were just a little high, and someone else was smart enough to see that this was wrong, but I was not. So in an integration test, you will miss a lot. It will just be hidden in the noise, whereas in a unit test, you will catch all the little bugs. I actually mostly write unit tests, and then the integration tests are a little, just a quick test to see if nothing fails if I just go through the whole thing. And yeah, that was most of what I wanted to tell you about testing. And oh yes, of course.
Do you generally recommend to have the tests in separate files or contained within the doc string?
Yes, I do not want tests to clutter my code. Definitely not. I always have a source code folder and a test folder. And the test folder has lots of files, many of them corresponding to source code files, testing those source code files. This is a very, very common way of structuring your application actually. Just have a separate test folder. And the nice thing is, because tests, of course, they do take up space. So if you publish your code to someone who will not develop, who will never change anything in the code, then there's no point in shipping the tests to them. So you can actually, when you actually make your code public, it's actually possible to include a version without your tests. Because people who just run your code, just users, just use it as a black box. They don't need the test. People who might develop it do, so do make it public one way or another. Yeah, definitely put it in a separate folder. Now if you read through this, which there's some good reading in this particular bit, which I've linked you to. You will find that it's very strict. Basically, the point is, if you don't have tests, then your results are meaningless, you're not allowed to publish, and yeah, basically, it's nonsense. So you might as well throw away your code entirely. I find that quite strong, but then I also find it quite hard to disagree with it. Because if I did a measurement in the laboratory with a machine, I would want that machine to be tested and calibrated. So why not with my software? And in the same way, of course, I must admit that every bit of software is tested. But I also know that statistically, everyone, brilliant programmers, complete novices, and everyone in between, which I think most of us can count ourselves as, everyone makes mistakes and everyone introduces bugs. So if you haven't tested for those, one way or another, then your code really is nonsense. You might as well throw it away. If you haven't tested in some nice structure, like with the unit tests, then your tests are simply kind of out there, so someone will just have to trust that you tested enough, as opposed to, I can show, I've done all these tests it runs. And then there's one more thing I'm going to tell you, and then I'll let you go. Or I think Martin still has some stuff to say.
yes.
Oh, you too? Other Martin, I was pointing at me. And there's one more thing that I will tell you, and that is the concept of, and you can also read about that here, continuous integration. So it's very easy, for example on GitHub, or with GitHub at least, to set up a system where externally all your unit tests are run automatically every night. So I write my code, I upload it to GitHub, and then the next morning I'll get an email, dude, you made a mistake, there's a bug, some of the test fails. And that is really nice if you, because especially some of these longer, some of the integration tests, you know, my integration tests, what, it might take an hour or two. I'm not going to do that every time. But if you just have this set up once, you never have to look at it again until you get a mistake, and then you just fix the bug. So definitely look into continuous integration for that.
But shouldn't you test before you upload?
Yes, of course you
Okay.
should.
Okay.
But
I mean, you can hook it with a commit, right?
yes, you can do a lot of things like that. But my problem is that I often have like short tests, which I run right away, and long tests, which take hours. And I don't want to wait an hour before I can commit. It's 5 o'clock or 6 o'clock. I want to go home and I want to commit, so I just run the short test. And then at night, I let the long test run. So that is one thing. The other thing is that it will often test on different environments. It will test on a Windows machine, a Linux machine, a Mac, maybe different versions of Python, all that kind of stuff. So I'm not going to do that myself. But yeah, you should definitely run your test before you commit. At least the basic ones. Yes?
Yeah, what about huge data sets or complex behavior? If the program is calculating complex stuff, how to unit test that? I mean, maybe it's not possible, or is it possible to use just small data, maybe a small matrix? And if it's working on that, assume that it will also work for big one?
Let me put it this way. It's a lot better to test on a small matrix than not test at all. That's step one.
Yeah.
And most people don't test at all, so whether it also works on a large on the large set, at some point you can't do that in an automated unit test, or even in an automated integration test, because at some point it just gets too big. You might need dedicated hardware. You might, you know, need one of the big supercomputers. No way you're going to unit test that. Then you get into a different domain. But use the unit test wherever you can use it. And again, units, the small bits, if all the small bits work, that will really increase your chances that the whole also works. It will greatly improve your code. So, it's a step forward? No, we're never there. It's never fully complete. Yes? So, Martin? Which Martin wants to go first?
I'll let you go first.
No, go.
In which case, I'll go first. Right, so there are two bits of installation that might be a good idea to set going now, ready for tomorrow. It'll take about 5 minutes. So if you go to the Etherpad and go to, I think it's about line 185. There are two little sections there: getting and installing Cycling, and installing Numba. Okay, so there are two tools that we're going to use tomorrow as part of the Making Your Code Run Faster session. Probably better to do that now whilst we're finishing the day off and making sure that that's installed properly rather than having to do it tomorrow. A few people have left early and then have to do that first thing in the morning. So that's all I wanted to say. Okay, where is it? So, Etherpad? Yeah, 185. There we go, so it's that section and that section, those two sections.
Yeah.
Is that so?
Good, thanks.
Exactly. About 14 minutes during the course of the day.
I have not checked.
Like very short teaching.
Yes.
Sometimes like I have an idea that there's a lot of checks and loops and how they
Just as Martin's getting ready to finish up finishing up, you've got an orange sticky near you. So just as we did at lunchtime, if you can give us something positive or something to improve, or both, that would be very useful.
It says that it cannot change into. Oh, somebody's changing. Okay. Now it works.
Yeah, because somebody's done it. Yeah, so it's that will unzip that directory. So when you do the CD, you have to CD into the directory.
Everything within this if
When it's Python setup pi install.
But before it was like that.
Yes. Yeah. So that takes a few minutes. So just leave it to complete and then do the.
So you have a lot of arguments that will go into all the different functions. So you will want object-oriented programming. That is what's also. Yeah, no, I see what you mean, and I must admit I've noticed that it somewhat depends on on your programming style. Some programming styles make it easier not to worry, but in general, this kind of stuff just means that you desperately need object-oriented programming.
What I don't like is everything is linear. Some global will be very.
Yeah, you have to be
So
careful.
like this, you can use this as a standalone function. But yeah. Okay, just saying if statement.
Yeah, so.
It's an algorithm, like which tests conditions and it's just an algorithm.
So I will usually, yeah, so you do have a remarkably large amount of if statements. But for example here, you have if robust is larger than 1, print this stuff. If you just said logger.debug and then this one, then you have one line. So that's the logging framework. That will help a lot with the robust. But that's only for that specific one. Yeah, I'm not saying it's easy. So you have a for loop in a while loop. So the entire body of this for loop, I would definitely make it change. That's quite a lot, right? You would need yeah, so all of those would have to go. So that's again where this entire list should be one object.
That's what I
Yeah, with like options or something.
Yeah, I could.
Yeah, so there that might just either you just have one object like a struct even. It doesn't even have to it just well you don't know what it's sorry, it's a struct is basically that's from C, so if you're not used to C. So I'm just talking about an object which just has like all your options. So you pass that object as in like a dictionary. Yeah, close to a dictionary. Yeah, so it's an object used as a dictionary.
If people don't have any objections, I'd like to take a few photos.
Yes.
So you don't want Facebook pages turn away.
That's
okay.
Yeah, tomorrow.
While the lunch break, there have been some questions. How can I get a history of what we have done today? So when you have been working in the bash, there's a command called history. So when you want to save your history, you just need to call history, and you will get all the commands that you have been writing in the bash the whole day. And if you want to save them, you of course can just simply redirect them to a file, and then they are stored there. You can take them at home and enjoy the history over Christmas or something like that. So for backup purposes and go through it again, just use history. You can even use that, like we have learned today, with pipes. You can grab for certain commands you have been looking for. You can remember the full command or something like that. You, for example, just can type history, grep. I did something with echo. Okay, echo hi there. Now I know again how to use the program because I looked at my history how to use it. Very useful if you cannot remember any commands you have written down in the past. So this is just to ask to give one answer for a question that wasn't there for lunch. Then let's talk about an evening event. Who of you would be interested in having a beer today, together with some of the group? Is anyone interested to go for a beer today, this evening? No. Okay. What about tomorrow? Who would be interested for a beer or dinner? Okay. So 1, 2, 3, 4. Okay. So it looks like that we possibly do that tomorrow evening with a small group. You may still think about if you join. So we will ask this question tomorrow, and then we can reserve a table for a small group. Then another organizational issue. Just this afternoon I got a call from my wife that one of our kids got sick, which basically means that she's scheduled for the next 2 days. And it could be that she's not able to reschedule her work, which means that possibly I'm not here for the next 2 days. However, I have a good feeling that you're nice people and you're a great group and that we have 2 excellent trainers. So the next day tomorrow shouldn't be that problem, because we also have Andrea, you have seen her here and there, and we also have Cedric and Sven, and they will be here for any help you need. And for Wednesday, possibly Lydia will show up already tomorrow afternoon and say shortly hi to you, so that you know that there will be another trainer on the last day, on Wednesday. And so I think I don't see any problems because everything has been already organized and everything should work smoothly. And I think Edwin and Martin are doing a great job, and Lydia is very keen as well, so I don't see any problem. However, it might be the worst case that I'm not here. Basically, that's the worst case for me, because I miss a great 2 days. In the end, are there any questions regarding this day, the next day's content, lessons, organization? If not, then we can quit this day. Many thanks.